Okay, we're going to continue writing equations of circles. We're going to do a couple harder problems today, a couple story problems. Since you felt more comfortable now knowing the equation of a circle and not just like me throwing everything at you. Yesterday, I always gave you the center and the radius. The first three problems here, we're going to look at what happens if you're not given the center and the radius. What happens if you're given the center and a point on the circle? What happens if you're given just the endpoints? How do you come up with the equation? Okay, just like in algebra, do they always give you the slope and the y-intercept of a line? No. Sometimes they give you 2 points and they say find the equation. Sometimes they give you the slope and 1 point. So this is kind of the same thing to that. Okay? But it's not, as long as you're given the center, the first two problems are not as bad as the last one. The last one's the hardest. So, if I look at the first problem, I'm given the center of the circle is 0, 0, and a point on the circle is 0, 4. I need to find the equation without graphing it. Without graphing it. So if I just think about the center in the equation of our circle, what would your equation start out looking like? What would the first part be? Because we don't know the radius. What would this part look like? Good. Just x squared. Because we know the center is 0, 0. It started off looking like x squared plus y squared equals something, right? If we knew the radius, we could square the radius. I'm going to leave this as r squared. Because we don't know r. In the first year I taught this, I made everybody do the distance formula. Then I realized there's an easier way. Do you guys remember in algebra, if you were given like 2 points, you would like plug one of the points in, and that would help you find the y-intercept? Remember doing that? That's what we're going to do here. I'm now, since I have the beginning of my equation, I'm now going to take 0 and 4 and plug that into my x and my y. And that'll give me r squared. So just like we do in algebra, if you're given 2 points, you plug in one of them. That's what we're going to do here. So I'm going to say, okay, 0 squared plus 4 squared will equal r squared. Well, what's 0 squared? Just 0. What's 4 squared? So 16 is equal to r squared. Now we really don't have to square root. It's helpful if we want to know the radius. The radius here is 4. But because we're writing in the equation of a circle, and the equation of a circle has to have r squared, I already solved for r squared. It's 16. So the equation looks like this. X squared plus y squared equals 16. So all you do is plug in, you have to plug in the point that's on the circle. Okay, you have to plug in the point that's on the circle. So you take your center, plug it in, get the beginning of your equation, take the second point, find r squared. Most people can do the first part, then they stop. And they just make it equal to r squared. Don't just leave it. The only letters you should have left at the end are x and y. Okay. Let's try one where the center's not 0, 0. So we're going to try negative 3, 3. And the point on the circle is negative 1, 2. So use your center. What would the beginning of my equation look like? X what? X minus 3 squared plus y plus 3 squared so x plus 3 squared y, or x minus 3 squared plus x plus 3 squared equals r squared, right? We got it from yesterday. So now this one gets tricky. a lot of people end up doing the algebra wrong. We're going to plug in -1 and 2 for our x and our y. So -1 minus 3 squared plus 2 plus 3 squared equals r squared. So there's a couple ways to do this in the calculator, but you just have to be careful. You can do it separately. -1 minus 3 squared. You can plug it in the way it looks, -1 minus 3 squared. Just make sure you realize if you plug this in and you get like, this is -4 squared, that you don't do this. Because the calculator will keep that in negative. Think about your radius has to be a positive number. Okay, so everything's got to turn positive here. Because radius is a distance. And isn't distance always positive? Right? At the point. So, I don't care how you do it. Just be careful when you get a negative. Because that's where people kind of tend to screw up. What's 2 plus 3? 5. So 5 squared equals r squared. So we got 16 plus 25, 41. So do you see now, I know on the first one it was, we could have taken the square root and we would have gotten 4. Here, the square root of 41 is not a nice number. So that's why you just kind of leave it the 41. So my equation is x minus 3 squared plus y plus 3 squared equals 41. So it's a lot of work to get to r squared, but you got to do it. And you don't have to show every step. As long as you show that you plugged it in, you're fine. Okay, so if you're given the center and a point on a circle, not too bad, right? Just plug it in, figure it out. C is the hard one. C, you're given the endpoints of the diameter. So it's looking at the circle, and you're given like this point and this point. So you're given 1, 6, and 5, -2. We have to find the equation of that circle without graphing it. So the first thing we need to figure out is the center. Okay, we got to figure out the center. Once I figure out the center, I can do what I did in A and B. How do you think I could figure out the center? Distance formula or midpoint formula. Right? Because isn't the center halfway between the two endpoints? Now, I used to make people do the distance formula, but the distance formula is annoying. Does everybody remember the midpoint formula? Remember, it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. So it's the average. This is the one formula not on the formula quiz that you will have to know for the quiz. Because there is a problem that looks like this on the quiz. So we got to do the midpoint so we can find the middle. We can find our center. Then I can do what I did in B. I can plug in one of the 2 points. So 1 will be x1, 6 will be y1, x2, y2. So 1 plus 5 divided by 2, 6 plus -2 divided by 2. So 3, 2. And I'm going to try to not give you one where you end up with a fraction. So our center here is at 3, 2. Now, we can do what we did in B. So our equation should start off with x minus 3 squared plus y minus 2 squared equals r squared. Which point do you want to plug in? You want to do 1, 6 or 5, negative 2? 1, 6. They're both positive. It's probably easier, right? So 1 minus 3 squared, 6 minus 2 squared equals r squared. One minus 3 squared is 4. 6 minus 2 squared, 16. What's 4 plus 16? 20. And then, so plug it in. X minus 3 squared plus y minus 2 squared equals 20. So again, like I said, that's the hardest one. Your first step, though, in these problems when you're given the diameter, is to find the center. That's your first step. Then, second step is plug in point to find r squared. And then write your equation. Okay. So yesterday you got the easy kind. Today they were a little more difficult. On your quiz, there's probably 2 of these. One with the center and the point, and then one with the 2 diameters. Questions, questions, questions. Okay, let's look at a story problem. Circles actually show up a lot in terms of real life. You use something with a circular thing every day when you use your cell phone. My cell phone towers have a circular, I don't know what to call it. Range, thank you. Same thing with radar, same thing with airplanes too. All have circular ranges. So here we have a cell phone tower on a coordinate grid is negative 3, 2. The range is 5 units. So the first thing we're going to do, write an equation that describes the position and the range of the tower. So let's say I had a map of Canton and I plotted a cell phone tower at negative 3, 2 and gave it a range of 5 units. My equation would be what? X plus 3 squared plus y minus 2 squared equals 25. So here's the interesting part. You know how when you go somewhere and you're like, I don't have cell service? That's because you're outside the range, right? You say that, you're like, I'm out of range service. That's because you're outside the circle of where the range of that cell phone tower is. So if your home is located at 1.5, do you receive service from the tower? So the way we're going to do this to figure this out, we're going to plug in 1.5 into our equation. If the number we get is less than our r squared, we're inside the circle, we get range. We get service. If the number we get is outside of 25, if it's greater than 25, we're outside the circle. If the number we get is equal to 25, that means we're on the edge. We're on the edge of the circle. Does that make sense? So we're going to plug in where we live. Let's do this over here. So for B, I'm going to plug in 1.5. So 1 plus 3 squared, 5 minus 2 squared is what with 25? Is it greater than, less than, or equal to? Okay, we don't know yet. Well, some of you do, because I can see that you're doing this. 1 plus 3 squared is 16. 5 minus 2 squared is 9. Oops. I almost put an equal sign. 16 plus 9 is 25. So because the number we get is equal to the radius squared, do you think we get cell service? Yes, but probably barely, right? So we probably barely get service because we're on the edge of the circle. So if this is our circle and our tower's here, we're like over here on the edge. Okay. So we might get service in some parts, but we might not, depending on where we are. Your friend's house is at 6, -5. Does she receive service? So we're going to do the same thing. Plug in 6 or -6, 5. -6 plus 3 squared plus 5 minus 2 squared is what with 25? So 9 So 18. Because 18 is less than 25, right? She gets service. She's inside the circle. Okay, so she's like down here. But she's inside the circle, so she gets service. If this number is greater than 25, you don't get service, you're outside the circle. Okay, that's one scenario we haven't run. Does that make sense? So she gets better service than you, so you might want to go to that friend's house. Questions? Just trying to relate it to your life. Another one that we use circles for a lot is fireworks. Where are the fireworks here? I don't know. Every 4th of July, Boston puts on a gala with the Boston Pops Orchestra, followed by a huge fireworks display. There is an explosion circle inside which all of the fireworks will explode. Spectators can sit outside a concentric safety circle, that's the dashed one, that is 800 feet from the center of the fireworks display. Find the approximate circumference of the safety circle. So our circumference formula is 2 pi r. Oops. Because the safety circle is 800 feet from the center, that's going to be our radius. So the circumference here is 2 pi times 800. So our circumference is 5,026.55 feet. That's a lot of feet but it's a safety circle. It's got to be big because fireworks are big. If the safety circle is 200 feet farther from the center than the explosion circle, find the equation of the explosion circle. So the radius from the center of our fireworks display to the safety circle is 800. They're saying the explosion circle is 200 feet, like, closer. What would be the radius there? If from here to here is 800, and there's a 200 feet difference, what's the radius? 600? Right, because it's 200 feet difference. We're going to just assume that the center is 0, 0, because it's not on like a graph. So the equation would be x squared plus y squared equals 600 squared, which is a real big number. 360,000. That's going to come in handy later, I think. Okay, organizers are going to spray the ground inside the explosion circle with fire retardant. Each gallon covers 1,000 square feet and costs $50. How much does it cost to protect the space? So this is kind of like the one problem where we're finding the area of the wall, except we're just finding the area of a circle. Okay, we know the radius of the explosion circle is 600. So we're going to find the area of the explosion circle. Then we can do what we did with the paint can. So we're going to do pi times 600 squared. Whoa. So the area of the circle, 1130973.36 square feet. That's a big circle. 1,000,000 square feet. But you guys have all seen fireworks. They're like humongous. So in order to find the fire retardant, each can will cover 1,000 square feet. So what should I do with my 1,000,000 square feet? Yeah, I'm going to divide it by 1,000 to figure out how many cans I have to buy. Or how many gallons. So I have to buy 1,131. Can I just say 31? Right, because you can't buy 0.97 of a gallon. So I have to buy 1,131 gallons of my fire retardant. They're $50 a gallon. So how much money do I have to spend? What am I going to do with that 50? Am I going to multiply this by 50 or divide it by 50? Multiply it by 50 because each gallon. So we're buying 1,131 gallons at $50 a piece. So the city's going to have to pay $56,000 to cover that area, which is a lot of money. All for fireworks. Questions? Okay, you decide that you're going to sit 700 feet east and 375 feet south of the center of the circles. Where are you in relation to the two circles? Are you outside the safety circle? Are you in between the safety circle and the explosion circle? Are you chilling inside the explosion circle? So we got to figure that out. I don't know why you would go there, but usually there's police.
In the safety circle.
So when it says, okay, think about directions, right? North, east, south, west. So if you're 700 feet east, you're like at positive 700. If you think about in relation to our, if you're 375 feet south, you're at a negative 375. We know the equation of the explosion circle, but we don't know the equation of the safety circle. We got to figure out that first. So the equation of the safety circle is going to be x squared plus y squared equals, the radius there was 800, 640,000. Okay, so we're going to check, because we have the equation of the explosion circle, the safety circle. I'm going to square both of these. If it's less than 360,000, I'm inside the explosion circle. If it's in between these two numbers, I'm in between the two circles. If it's bigger than this, I'm chilling outside the safety circle. Does that make sense? Think about the numbers. So, let's plug these in. So 700 squared, negative 375 squared is what? We'll stick with the safety circle, 64,000. But less than, greater than. I'm going to do this all in one. 700 squared plus negative 375 squared. So you get 636.25. That is less than 640,000. And it's more than 360,000. So it's in between the safety circle, the explosion circle and the safety circle. So I'm in between the two circles. Does that make sense? Sure. So I'm in between the two circles. Oops. So if you think about, like, that picture's not very good. You have the explosion circle here. The safety circle is here. I'm chilling in between. Because the number I got was in between the two radiuses squared. So I'm here. Questions?